Hi, I'm Greg Hanson. I am a software developer with IBM, and like Lynn said, I've been a core contributor for the Istio project. But today, I am going to tell the story of one team's journey to adopting Istio in their service. So the previous presentation ties in really well with this, and I'm glad they went before me, because I'll be reiterating some of those same features. But before I go any further, like Lynn said, I need to give a shout out to Martin Ross and the AppConnect team. I am presenting in their place today since they couldn't be here themselves. They put in most of the hard work, and I, as a developer and maintainer of Istio, became their lead contact for all their troubleshooting needs. So, what is AppConnect? AppConnect is an integration platform as a service that provides support for a range of styles such as events, APIs, and batch processing. The AppConnect service itself is composed of over 150 different microservices, each on a replica set with a minimum of 3 replicas per service. So, as a result, the AppConnect service handles over 20 million requests per day, ranging from users interacting with the UI, calls from scheduled flows, service-to-service calls within the mesh, and calls to target applications hosted externally, usually system-as-a-service endpoints. AppConnect integrates with hundreds of endpoints and applications. The service itself relies on external applications such as CloudInt, Elasticsearch, Redis, Kafka, and Sysdig, to name a few. But it also supports additional endpoints through the use of connectors, which get configured by the end user. Examples of some of these connectors are for Salesforce systems, DB2 systems, or any standard HTTP REST endpoint. So, just a quick example here of what a user of AppConnect might see. In this particular case, they're creating a flow from a template, and this flow, which runs periodically, gets the leads for a particular account, sends out some notifications, and then via Slack or email to each lead, and then saves a database entry in a backend. And kind of putting that into a simple little diagram, you have incoming traffic coming from users, applications, or those scheduled flows. And the AppConnect service itself, each of the different microservices handle the request, making calls to external applications such as monitoring, alerts, logging, authentication, etc., and eventually to the corresponding connectors, which interact with the configured SAS Target application. Now, let's talk about AppConnect prior to Istio. AppConnect and all of its services were originally written all in Node.js. They wrote and published their own NPM modules for wrappers, which perform consistent logging, metrics, and retry logic for all their internal and external traffic across all the microservices. And since everything was in Node.js, the department could skill up and code share pretty easily, and the programmers within the team could move around between different components pretty smoothly. But as more connectors were added, they discovered different connectors needed to be in different languages, Java for instance. So their common wrappers could no longer be just dropped right in. They needed to move towards supporting polyglot runtimes. And for those of you that haven't heard the polyglot word before, it means that services can be written in a mix of any programming language. And a little bit about their environment. IBM originally didn't have a Kubernetes-based cloud offering when AppConnect GA'd and started their initial development. So the team adopted a homegrown and non-declarative model for deployment. Services were all deployed via a configurable bash script with a bunch of Cloud Foundry deploy commands, which had to wait for each one to complete, and they had to be run sequentially, and they took hours to eventually complete. So at the time, they were not strictly following 12-factor application and cloud-native practices. All those things about saying, having a CI and continuous delivery model for all of your applications and services. So just a quick example of a use case a user may have in this Cloud Foundry environment. The user interacts with the UI microservice to create a flow, And then a separate authoring service stores that user-created flow in a database backend. And behind the scenes, those wrapper libraries are calling external services for logging, alerting, and monitoring services. And one more, a little bit more complex example. A user creates an API that is exposed and can be called by other applications. The API service receives the request, and it's sent to a separate logging service meant specifically for user logs, and stores those in an Elasticsearch backend. And then it also continues the request onto those various connectors, which could be one too many, to call those SAS endpoints. But the API service also calls a separate billing service to record the number of times a particular API is called so that the end user can eventually be billed for that. And once again, those wrappers for each component are all using those external logging and alerting monitoring services. So the AppConnect team had some areas that they wanted to improve upon. They were using a very homegrown deployment model and wanted to move to a declarative and more cloud-native model. And additionally, all the circuit breaking and retry logic was currently hard-coded using those shared wrapper libraries, which does not work well as the team moves towards polyglot runtimes. The current workaround for those Java apps is actually to deploy 2 containers in their Java pods, one for their Node.js wrapper, and then one for the actual Java pod itself. But they're still stuck with maintaining those wrapper libraries themselves. Also, the UI developers in particular were very interested in canary testing, opening up the ability to share workloads between different service versions for testing and staging purposes. The team also wanted better visibility on their error rates, their interactions with external systems, and ingress. Because in their Cloud Foundry environment, there's a Go router, which sits in front of their AppConnect service, and it performs a lot of things behind the scenes. And the team wanted better observability and metrics on, say, all these rejected calls or the successful calls. So, why Istio? And similar to Linkerd, Istio is an open platform service mesh to connect, manage, observe, and secure your microservices. And so AppConnect originally started with only 10 services, but like I mentioned previously, they're up to 150 different ones. And they're expanding and moving to polyglot runtimes. They also did not want to maintain those wrapper libraries that perform the consistent logging, metrics, and retries across their entire service. They wanted to explore using Jaeger and Kiali, specifically for observability in those end-to-end transactions and requests. And those specifically are installed as add-ons with Istio, and they provide tracing and visual graphs to observe traffic within your mesh. They also, sorry about that. They also wanted better workload control with focus on canary testing and traffic splitting. And they wanted to utilize the error injection for making more robust and stable microservices. And also, Istio has community support. And within IBM, they are developing on Istio. So they had somebody that they could reach out to on Slack and ask for questions. But also, Istio itself has community support on GitHub and discuss.io. And Istio itself had a lot of features that they were interested in playing with, but these were the ones that immediately caught their eyes. So going back to that same diagram as earlier, except deployed with Istio on Kubernetes. The requests come in through the Ingress Gateway, which use a combination of virtual and gateway rules, and these eventually route to the microservices that compose AppConnect. The services themselves then use service entry rules to communicate with the external applications for monitoring, alerting, and logging, and security, among others. And at the bottom, those are those SAS target applications the connectors talk to. AppConnect supports a variety of SAS targets, and as a result, cannot define all the service entries that might be needed for deployment for different connectors a user may set up down the line. So as a workaround, the team is using the include outbound IP ranges notation within Istio, and I'll show an example of that later on. And once again, just looking at that same scenario where a user creates a flow, it comes in through the ingress gateway, and there's a gateway and virtual service rule to direct traffic to the UI microservice. And these services communicate with the external logging, alerting, and storage services using those service entries. And I should mention, not shown on here, is the Istio control plane, which handles things such as certs and pushing the Envoy configurations to the Istio proxy sidecars, also mentioned in the previous talk, that run along each of your services in a service mesh. And so looking at a similar setup for that user-exposed API example. The application calls the API service going through the ingress gateway, and service entries for all the external applications except those SAS target applications for the connectors. And notice within the mesh, there are not any rules needed for communication from the API service to any of the others, such as the logging, the connectors, or the billing. This is because with Istio, default routing works, well, by default. So just here is a sample gateway rule that they're using for controlling ingress into the App Connect service. Gateway rules in Istio describe ports which are exposed to traffic coming from outside the mesh, as well as what the protocol type, SNI configuration, certs, and similar. In this rule, port 443 is open for requests for host names, matching the App Connect domains specified at the bottom. And as you can see, it has TLS enabled. And something to note, in this particular setup, they do not have HTTP defined for their gateway. And this is because for their particular production system, they have a Cloudflare instance running in front of it that enforces all traffic to be HTTPS. So no HTTP block was required. And virtual service rule. Virtual service rules define how traffic is routed to a service within the mesh. For this one here, it defines the routing behavior for the port-host combination defined in that gateway. It matches on a particular host name for the request and routes to the destination host and port. And even though this virtual service is defined with HTTP, this also works with Istio auth enabled, which will automatically upgrade traffic to HTTPS. So the traffic in this case would be from that Istio ingress gateway instance to the Istio proxy sidecar that's running along the UI service. And here is an example service entry. Service entry rules define services that are not automatically discoverable within the mesh, so that internal services can route to them. So this one here is for Elasticsearch, and I should mention that URL is made up, so please don't try and reach out to it. But it also defines a port and a protocol there for that one. And here is an example for one of their HTTP connectors. I had mentioned the include outbound IP ranges notation before. For those not aware, this annotation is used to decide what traffic is actually sent to the Envoy proxy sidecar, which runs alongside their service. The way it is configured now, basically all local traffic within the mesh is caught by the proxy and runs through that Envoy proxy, but everything else bypasses it. Since App Connect service doesn't know all the endpoints the user may specify when configuring a connector, this is the current workaround. They're still investigating alternative solutions for this because they eventually want observability and metrics on those calls to external applications. So, where is App Connect team today with Istio? They have been using it for over a year now. Istio version 1.0.4 was the first one installed on one of their primary clusters, but they have been playing around with versions as early as 0.9 and 0.7 in their test environments. They have a pre-prod system up and running, everything deployed using pipelines, and testing is currently underway for validation and scale purposes. They also have a production environment deployed, and it's waiting for that testing to complete. Their current environments have the Istio ingress gateway installed with auto injection enabled, which automatically deploys that Istio proxy sidecar along each of their services automatically. They also have MTLS enabled globally, So that traffic between the proxies within the mesh just by default. And they're also using the rewrite app HTTP probe notation, which is something needed once MTLS is enabled. This flag tells the injector to rewrite the liveness health check in the pod spec to redirect traffic to the sidecar instead. Since Kubernetes health check requests are sent from kubelet, which does not have the Istio issued certificates. So when mutual TLS is enabled, those health checks actually fail, which if you're not expecting it, it's something that's very confusing. All right, and yeah, they are up to 150 different microservices now with those replicas of each one. So close to 500 containers alone, and doubling that once you, of course, add in the Istio proxy sidecar container that's running along all their apps. And their first Istio-based deployment is actually only going to be for one customer. They're onboarding this one customer because it represents the majority of the traffic for their service. So once the team verifies the successful transition of that one, they'll start staging everyone else in early next year. So let's talk a little bit about their adoption process. They ran into some stability issues with Istio prior to version 1.1, 503 specifically. And for those of you that remember those days, 503s were quite the bane of Istio's existence, which made the team's initial attempts more difficult to diagnose and debug along the way. But they're not seeing those 503s anymore. And it was a learning experience for their team, understanding in finer detail how their services talk to external endpoints. Personally, one time I was poring over some trace Envoy level access logs with them, wondering why particular requests were failing to cloud in. And eventually, we find out that it was a wildcard domain defined for one of their service entries, and it just happened to be missing like 1 out of the 5 URLs that the service was trying to communicate with. But they didn't know that it was communicating with that one, and so hence the failure. Another pain point was pod startup time. When you inject the sidecar proxy to services to deployment, it takes a little bit for the proxy to spin up. And a lot of their services were always expecting to have networking available at startup. So their services would fail the initial calls to set up connections to external applications, and some of them were never retrying on failure. And in a few instances, they also didn't crash on failure. So these services would come up, fail to connect to this external, say, database, stay up, but then not actually be able to process any incoming requests. As a result, the team did end up identifying bugs in their application, the results of just bad coding practices creeping in over time. But on the plus side, Istio and Kubernetes were a way to discover these bugs and move towards a more cloud-native and 12-factor application. Another item was implementing the ingress solution, which was not as straightforward, and it's because ingress usually ends up being partly environment specific. And I have a slide to follow for that one. Also, they needed to decide how deployments are handled, specifically with automating the updates of Istio versions. Because while Istio does have long-term support for so many previous versions, they do eventually need to be updated. And so their current solution right now is to perform some manual testing, then run component and integration tests, and eventually promote to production using pipelines. The team also wants to be able to start using more features of Istio, but currently a number of them are disabled during deployment. The team found that some failures were getting introduced in components that they weren't actively using. But since they weren't using them, they weren't looking for errors in those specific components. So for example, even though the team wasn't using Prometheus for observability, Prometheus ended up running away with resources on the cluster, which resulted in scheduling errors for other services in that cluster. And another thing was one of the times they tried to delete one of the workers in their cluster, but during one of the version updates of Istio, Mixer had a requirement that it needed a minimum of 1 instances to keep running. But when they deleted that worker instance, they accidentally deleted that telemetry instance for Mixer, and then they started running into problems, even though at the time they were not actually using Mixer. But they are currently going to prod with Istio 1.2.7 and have begun testing with 1.3.4. And I hope they start testing with 1.4 because for those of you that don't know, that did release last week. So just going over some of those specific Istio components that they're using. For the ingress gateway, this is a setup for a multi-zone cluster. It's a little environment specific, so I won't go into too much detail. This ended up being one of their pain points because at the time of their implementation, Istio docs were kind of lacking for multi-zone as well as IBM's own. But the App Connect service has 3 public IPs. They have a cloned network load balancer service for each availability zone, and they have that modified to point to different IPs for each AZ. And then behind each network load balancer is an Istio ingress gateway and the specific services running for that AZ. So when a client calls this DNS service, which has been performing health checks on each Istio ingress gateway for each AZ, it'll only return a healthy endpoint. So that client gets a IP for a specific availability zone and completes its request. App Connect is also running with Istio Auth enabled. So all the services within the mesh are communicating with each other through their local proxies using MTLS. But this was added in after everything else was working. So that means ingress, the auto injection, and routing. They started with disabled, moved to passive, and eventually strict. And as you can see, the Istio team, the App Connect team is currently only using Pilot and Citadel, and Galley should be up there. So once again, Pilot is pushing those configs to each of the Envoy proxies. Citadel is managing the certs, and Galley is performing config validations for all the incoming rules. But the other components are disabled. So looking forward, the App Connect team still has more features that it wants to adopt. It wants observability with Kiali and Jaeger. They want to move to 1.3 and eventually 1.4. And they also want to adopt the operator model for installing things across their service. They also want to perform locale-aware routing. So going back to that multi-zone example, if service A instance is calling a service B instance, ideally that service B instance should be in the same availability zone as the one making the call. They also want to play with fault injection. They learned a lot of things about how their services were written and how resilient they were to failures on startup. And they want to keep exploring those dependencies and failures so they can be prevented in the future and make more robust applications. And they also want to start playing around with the canary testing. So starting to split traffic between different service versions for staging and testing purposes. And so some words of wisdom from the App Connect team for those thinking of trying something similar with their own service. Disable components not in use. Don't need to introduce failures if you don't need to be using that component. Also, think about how ingress will be handled in your environment. One of the things to think about is, do you want to chain your existing ingress solution to a Istio ingress gateway, or just dive straight in with Istios? For the App Connect team, they were already switching from Cloud Foundry to Kubernetes. So they were doing away with their existing ingress implementation anyways, and it was easier for them to just dive right in with Istios. Something else, make sure you're enforcing good development practices. Make sure you're thinking cloud native and 12-factor. Also, please learn about how your applications talk to your external endpoints and how your services interact with them, especially on failure. Also, think about how you want to handle updates for Istio, since they will happen. You want the latest and greatest, so make sure you're ready for them when they come out. And one other thing the team wanted to stress with auto-injection is they were surprised that once they got it working, there were a few bugs with their first initial passes, but once you figure it out, you deploy your service, it's injected with the sidecar, and communication just works within your mesh. And so that's about all I had. Do I have any time for questions, Lynn? Okay, perfect. But of course, if people just want to go out for snacks, I would be more than open to that. Yeah, in the front there.
Are there any performance problems? And if so, how did you rectify them?
So performance testing is currently underway right now in their environment. Unfortunately, I don't have the data on that, but if you want, you can reach out to the feedback form on the service mesh schedule, and I can get you in touch with the App Connect team. Anybody else?
How do you handle the canary release in production environment with Istio?
So it's something they want to implement down the line. They haven't done it yet. So the question was, how do you want to handle, or how are you currently handling canary deployments in your production environment? And the answer is, unfortunately, they are not doing it yet. So I cannot provide an exact answer to that. In the front here?
Are the other teams beside Connect at IBM who are using Istio service mesh?
Let's see. In production, I can't say for sure, but there are other teams that are using it for deployments. Similar. Actually, those people are using canary testing for their deployments, but I do not know off the top of my head. Yeah, we have several teams in the UK that have been playing around with App Connect. I don't know, Lynn, am I missing anybody? Or sorry, several teams in the UK that have been playing around with Istio. But am I missing any other big internal users of Istio within IBM?
Yeah, so sorry, I had a question asking about break. We do have other teams. So the weather company was the first team actually adopting Istio, and we thought it would be really interesting to have the App Connect team talking to you because they are actually running the larger scale with 500 containers. We also have internally, we have actually a lot of team. We have an API team, we have a Watson team. A lot of the teams are actually come to the Istio team because we have an architecture car wash program inside of IBM, and as part of the program, the architecture team wants each of the microservices make sure they have secure communication, secure identity, and Istio is often proposed as a solution to that. So there's a lot of a team inside of IBM actually looking and even adopting Istio for that reason, just for mutual TLS.
There in the aisle.
Did you need to make any changes for communication within service mesh and outside? Back and forth, not just service entry outside, but both team design.
So external applications calling into the mesh? Or so with App Connect, they have a way to define APIs that are exposed. So that actually would end up going in through the ingress gateway to the App Connect's official API service, which handles the request and processes it.
So it was more like this is a separate application and you had to go through the data. Did you have to experience anything like, you are within the cluster, but service mesh is enabled only for a bunch of services, not all of them?
Let's see. So. So basically services within the mesh, and some of them are, I guess, local but external to the mesh. Is that what I'm hearing?
Yeah. I mean, maybe double tap on the include out of bounds.
Yeah. I'm assuming part of that, if they are running into it, is covered by the include outbound IP Istio range, Istio notation. But for that specific example, I don't have an answer for that. If it's something you are interested in, though, please submit feedback through the sketch form. Yes, the Istio multi-zone. Did you have some follow-up questions on that, or? That one slide was about it, just with regards to respect for time. It's kind of a little complicated, just because, like I said, it is environment specific for IKS, IBM Cloud Kubernetes Service, which is where they're running now. And I'm sure it's going to be something similar for a lot of people, depending on which environment that you're implementing in. But if you would like to know more about it, like I said, please submit something through the feedback form on Sketch, and I can get you in touch with someone. In the front there? Yes, they are all up on the Sketch. They are added as part of my presentation, so you can download everything there. And I think most of my speech is included as notes in the presentation, so.
Thank you so much, Greg. Let's give him a round of applause.